Welcome, everyone. Welcome, Elliot. We're just getting rolling here. I'm going to start with two questions that were sent to me earlier today. You're seeing them on screen. The first question that was asked me is about number 19 on section 3.6. If you want the page, that's page 165. And the directions were, show that this find out if this is a valid argument or not using a truth table. And this is what they give you in the book. They give you the argument. We have two premises and a conclusion. We're supposed to show that this is valid or invalid using a truth table. So make a truth table. And let's see, I got to quiet the pictures here, make this a little bit bigger. So we've got to make a truth table. We have three letters. So therefore, I'm sorry, we have two letters, P and Q. So good news, we only need 4 rows. So that meant I could set up my truth table, look something like this. Premises were simple. By the way, you notice I did swap the P1 and the P2. That doesn't matter as long as they're both up here. You know, up on the top, P1 is first, P2 is second. As long as you've got them both, it doesn't matter. I don't know if you want me to show the detail here, but I mean not P. That's just the opposite of the P. So all I had to do is reverse that, FFTT. The second premise, if P then Q, famous one, what? Only false when the first one's true and the second one's false. The other three are true. And then the conclusion is just Q, so all I had to do is copy it. TF, TF, TF. So now we're looking at we're looking at our truth table and which rows have all the premises true. Well, in this case, 2 premises. And these bottom 2 here are the only 2 where P1 and P2 are true. And then here's the troublemaker right here. One of the conclusions in the circled premise is false. So the bottom line is this is an invalid argument. So let me just see if there's any follow-up. That was the first question requested here, number 19 on 3.6. I'm going to go to the second one that was requested, which is also on 3.6. Happens to be number 21. So here's number 21. Again, same deal. They give us the argument. This is exactly out of the book, except that I added the P1, P2, and C off to the right there. So we're supposed to see if this is valid or invalid using a truth table. I guess if there's a little bit of bad news, P, Q, R, we do have 3 letters, so we're going to need 8 rows. Okay, so let's set up the 8 rows. Let's see, I'm going to have to get rid of this. It's going to be a little hard to see here. I'm going to have to do some scrolling. So this is page 165 again, so I'm going to cover up the problem for the time being so you can see the whole truth table. So I set up a column for each of the premises and the conclusion. These 3, that mean, these 3. Of course, I have to set up the PQR thing. And in order to do that, I need to, what? Go half and half first. So 4 trues, 4 false. And then the second row, Q, go by 2s to TT, FF, TT, FF. and the last one, R, go by ones, TF, 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 TF. Marco, welcome.
Hello.
We're, Marco, we're working on a requested problem right now from page 165, number 21. So just so you know what we're working on.
Okay, thank you.
Yep. So we had just set up the truth table here. We've got our PQR thing over here on the left, and then we set up a column. Each of the three. I'm gonna have to. Okay. You have to mute you, Marco.
Okay.
We got some feedback issues, but unmute yourself when you want to ask a question. I'm sorry about that. All right. So anyway, these three, the P1, the P2, and the C, those are just given in the book. Those are those premises inclusion in the top. So cover them up again. So I don't know what you want to see, but I made up the truth table, and turned out I had 1, 2, 3, 4 rows in the truth table that had both premises true, and not a one of them has a false conclusion. So bottom line on the bottom here is this really does look valid. Now, again, that's, I don't know. I'll open it up to you guys. What how is there any? Do you want any detail here? Do you want to talk about one of the columns or anything like that? I'll just explain why a couple of these are red. You know, you can either look over here on the left and put asterisks over here and make a, you know, I could have made a column for not R and not P over here, which I've done. In this case, I just stuck not R and not P in here in red. Honestly, the first time I did it head, and that's why there were no red columns. But to show more detail, I threw not R in here in red, and I threw not P in here in red, and then I did the if then. And so I don't know. Let me know if you'd like some detail, but that's how number 21 can look. And by the way, any one of you, I'm looking, you can use the group chat, you can send me a text, or you can just speak up and say, here's a problem I'd like to see done. Okay, so these happen to both be from lesson 3.6. So I'll tell you what, let's see if there are any more questions that are not on the practice test. As long as we started with a couple that were not on the practice test, let's see if there are any more. Any more questions not on the practice test?
Can we look at number 15 on 3.7?
Yes. 3.7, number 15. Okay. I will go there. So this is, as you heard, lesson 3.7, number 15 coming up. Yeah, I got to get the context here. So it says, draw a pair of switching networks to indicate that the statements are equivalent. I'm not sure the switching network. Why say a pair?
Yeah, my biggest problem with the question was I didn't understand the and P at the end of it. I didn't understand.
Yeah, and you know what? I'm having a little trouble with that. I'm actually struggling with that a little bit too. You know, here's the problem. I did it. You see how I did the and P over here. I did the other part over here. But to be honest, that doesn't show they're equivalent. It's not obvious by looking at the diagrams that they're equivalent. So that's the problem, the only problem I have with the question. So the important thing here, I don't blame you for having a little trouble with that. That's not well done. But anyway, I'm sure you didn't have any trouble drawing the switching networks. I doubt it.
Not on that one. I just, like I said, I didn't understand the NP, and that threw me for a loop. But I got the rest of it, so I just that one part. So
you know what they're telling you is that this logic statement is equivalent to this one, and if we did it in a truth table, I could prove to you that they were. But you can't really see that by looking at the two switching networks drawn. So that's my quibble with the question. It's not really visible that they're equivalent by looking at those two. So not a very good question, to be honest. So right now, the important thing is that you know how to do the switching networks for each. And maybe as a separate question, I might ask you, show me with a truth table that these two are equivalent. And then you'd have to do a truth table and show that the final columns were identical. So that would be the difference in how I would ask this kind of material. I'd probably have to have two questions to do that. Does that make sense, Russ?
yes, it does.
Okay, I'm sorry. That was a good question, and the books really wasn't a very good one. Other questions not on the practice test? I mean, it's not like I want to avoid that. That's what I want to spend most of the time with. But as long as we had some others, I thought that would be good to go through those. All right, I'm going to move to the practice test. We can always come back. So the practice test, you know how this works. It's very similar to the kind of test I give you. It starts on page 175, and there were 25 questions. So I'll let you have it. Let me have your questions on the practice test now.
Can you do question 7?
Sure can.
Thanks.
Yeah, here's what it looks like on the test, but I've got a page set up for it, so let's take a look. Okay, a little bit blurry, but here's question number 7. So basically, this is a multiple choice question, and it says in the table below, which of the truth tables under A, B, C, D, and E, which one matches these statements? So let's take a look at, let me change this to blue. Which column is not P? So all you got to do is look over here, and that's TTFF. So which column is FFTT? And that's C, right?
Right.
So that's that one. If P, then Q, the second one. Remember how that one works? Only false when the first is true, the second is false.
Mm-hmm.
And that would be this row. Okay, which column only has a false in the second row and none others?
Is it row Q? Q? It's a little blurry. I can't really see.
That you mean that column?
I was going towards it. Yeah, D. D.
Yeah, that's it.
Okay.
Okay, by the way, you don't have to be the only one to answer this, but good job. Okay, how about the next one? P and Q. So that's what? That's the rule, true only when they're both true?
Right.
So which of the 5 columns is only true on the first row?
This is where I got lost.
But just look here. This row A has TFFT. Row B has TFFF. It is, isn't it? It's only true when both are true.
Yeah, that's true.
So that's it. That's our guy.
Okay.
And then this next one, P or Q, the inclusive or. That's what? Only false when they're both false?
Correct.
So that's this row down here. They're both false, which is the only column that only has a false on the bottom.
Let's see.
E.
Yeah, because it's P or Q.
Right here. I know it's a little bit blurry, so you guys maybe can't see this. But that's the one right there. So, and then there's one more. This one over here, P if and only if Q, the biconditional. True only when they're alike.
Right.
And that's on the top and the bottom, and sure enough, here it is. See it?
Yeah.
So that's what that was. That was just to see if you knew your rules.
Okay.
Okay, next test. Oh, number 19, Michelle said. On the test, Michelle. Okay, got it. Sorry, I wasn't looking over in the chat room. Okay, number 19. Okay. Well, I don't know if I should start over. I think I will. Let me erase. Okay, you're supposed to use an Euler diagram to find the validity of this argument. So, Michelle, the first thing, and anybody watching, the first thing we want to do is translate these sentences up at the top into you know, logic statements. All students study hard. So in other words, if you're a student, then you study hard. This is my translation of that right there. John is not a student, therefore John does not study hard. Okay, all students study hard. I drew that this way. If you're a student, then you study hard. Remember, the if part has to be in the inside. Okay, second line. John is not a student. So where does John go? John could be here. John could be there, correct? We don't know. We don't know if he's inside the H circle or not. So when it says in the conclusion, he's not in H, that can't be valid, right? Because we can see he might be inside. So hopefully then get this conclusion down, invalid.
Thank you.
You're welcome, Michelle. Another test question. Okay, 22. Oh, we're going to have to put that one in. All right, let's find it. 22. Oh, check the validity. Use a truth table to do number 20. Okay, got it. So I'm going to go back to number 20. Yeah, so 22 is on the, so 20 you were supposed to do with a Euler diagram, but we're going to look down here. This is the 22. Okay, 22 says go back and do 20 with the Euler diagram. So I don't know, Susan, whether you use the same coding I did, but no loafers work hard. So I wrote that this way. If you're a loafer, then you don't work hard. Sally does not work hard, so not W. Sally is a loafer, therefore L. So this is the way I coded the argument. Of course, the way you code the argument will greatly affect what your truth table looks like. So, good news. We only have 2 letters, L and W, so we only need 4 rows. I threw a column in, as you can see here, for not W. Again, it depends on how you want to do it. So then when I did my first premise here, I could use the these 2 asterisk columns, if L, then not W. And it's only false when the first is true and the second is false, and that only happens up here on the top. Let me, yeah, that only happens on the top. Anyway, and then premise 2 is not W. Well, I just copy, I got a copy of it right here. So FT, just put it in. And then for L, I already have that. I just copied that over here. Now it's just a matter of identifying all the rows where both the premises are true. And as you can tell, we're good on this top one, but the bottom one right there, we do have 1 false conclusion. So this one is going to have to be invalid. So again, Susan, if you coded that with different letters, this may look like a whole different problem to you, but I mean, you code it differently.
Negative L. I was trying to make it work with negative.
Oh yeah, so you said if you're not a loafer, yeah. You know, this is a hard one to, this sentence up here is a hard one to translate. You're right, that would make it hard to do. But would you agree that another way to say no loafers work hard is, if you're a loafer, you don't work hard? Yeah.
Yeah.
Okay, so that was number 22, which made use of problem number 20.
Number 18.
18, I see a request here from Michelle, number 18, okay. 18 is next. Which of the following statements are tautologies? So a tautology, remember that term? You guys need to remember that a tautology is a truth table that comes out with all truths in the final answer column. So all you gotta do is make a truth table and find out. Here's A right here. Well, that's sure not a tautology. Turned out to be all falses. Here's B. Look at that. That one works. And finally, C did not work. So B is the tautology.
So thank you. So on the test, we have to make sure that we just, show the work for each problem rather than just saying B is the answer. Correct?
Well, The thing is that there's no way to know if you don't.
Got it.
I don't.
Okay.
I don't know of any way to avoid the work. Okay, I need to do the work. So if I need to do the work, I don't know what else I would do. Yeah, I would say, boy, if you could show your truth table. Actually, if you could, Michelle, if you just show me this much,
Mm-hmm.
if you just showed me that came out to TTTT, that's enough. I would give you full credit.
I was just asking. Thank you.
Yeah, Michelle, another aspect of what you asked me is when they say which of these are tautologies, it kind of gives the impression there might be more than one, doesn't it? So in other words, I really did have to check out all three of them. Anyway, yeah, the truth table definitely is the work that needs to be seen here, because if you can show me it's TTTT, well, then you did it. Anyone else? Test question? Let's see. Ron left the chat. Left the session. I hope he didn't have trouble.
Could we do number 15 then?
You bet. 15 on the test. Coming up. Okay. So let P be you get overtime pay. Let M be you work for more than 40 hours per week. Symbolize the following statements. Okay. So if you work more than a 40-hour week, so that's what? If M, then you get overtime pay. That's really all they're asking for, Marco, is just using the symbols, that they gave you up on the top. I'm not Marco, I'm sorry, this is Russ. I can tell by the voice. So let's do B. You get overtime pay only if, remember I taught you guys to watch for that phrase, only if? Whenever you see that, it's the same as if you get overtime pay and you work more than a 40 hour. So that means if P, then M. So whenever you see the words only if, it's as if the first part of the sentence before it had an if on it, and the second part of the sentence after it had the then on it. That's all there is to that one. In part C, oh, if and only if. So now it's the double-sided arrow. And by the way, that one could be written this way. I mean, these two are the same. Either one of those is correct. So when you see the words if and only if, you got to use that double-sided arrow symbol. And then this B was that tricky one where you had to watch for those words, only if. I don't think A was pretty straightforward. Any follow-up on that one, Russ?
Nope, I'm good.
You have 24.
Okay, 24. Thank you. All right. Actually, yeah, my apologies, but I would have to throw this one out. because this is the second half of 3.7 that I decided not to teach you the other night. So my apologies for making you struggle with this. I mean, I'll show you how to do it, but we didn't have time to go through this, so yeah, we probably should just skip it. I'm sorry I should have told you that 24 was out. Questions on the test?
Number 25.
Okay, thank you. 25. Construct a switching network. Okay. So what made that tricky was I showed you how to draw a switching network for an if-then, correct? Do you remember, you guys, I only showed you how to do this and this, right? So what in the world is this doing here then? And the answer is, well, look at what's over here in the box. Do you remember this identity? If not, here's where it's from. I've asked you to note this before, but I would say definitely put it in your notes. Remember, I'm letting you use your notes on your test. But look at page 165, number 23. You'll see, what is it? I think they called it a hint. Whenever you have an if-then, you can change it to an or. All you do is take the first the part on the if side, make it a not, and change the if-then into an or. And they're exactly equivalent. And so if you look at what I did in the problem, I switched the if-thens into ors using that notation. So here's my new rewritten statement. And that one, I did teach you how to draw a switching network for. Let me just make a pause. So because of this huge hint, you're actually able to do this problem. So first I translated it. Let me just show you if P then Q. See how I took the P and I made it not, and then I changed the if then into an or. Okay, and on the second one over here, I changed the first to a not. Well, what happens when you not a not P? It becomes a regular P. And then I changed the if-then into an or. So here's my new statement. Can we draw that? Sure. So first we have a stack, because you can see the first part of an or. So do you see I made a stack over here on the left? And not P and Q, doesn't matter which is on top or bottom. Here we have another stack over here on the right. This time we have a P and a not Q. And then because of the and, they are what? Side by side. So that would be your switching network. So what made that one a challenge was those if-thens in the problem. Like, what? He never showed us how to draw those. You are right, I did not. But because you know how to change an if-then into an or, it can be done. Maybe, so 25 is a little bit over the top for difficulty, but with your notes wide open, that should fair game. So this thing way on the top right there, that identity in the box, you want to put that in a special place in your notebooks just in case you come up with a problem like this one. So it's more than just a hint on page 165. It turns out to be something, it's kind of almost like having an important extra power tool in your work belt. Ah, 25. All right. Oh, I guess Ron already asked. Okay, so we did that one. Thank you. So 2 people asked for number 25. Yeah, and you should have. I could see where that one would have stalled you. Yep. Thanks for firing the questions, guys. Keep them coming. We've got we've got plenty of time left. What should we do? What else should we do on the practice test? Or if you want, we can go back to just regular problems from the assignments too. That'd be fine. Sounds like somebody's trying to ask a question. Please do.
Number 17.
Got it. Number 17. Oh, Michelle, thank you for asking this one. Okay, this one always gives people trouble. So everybody, let me cover this up here. What is an implication? You've got to know this for the test. What's an implication? An implication is what? An if-then statement that turns out to a tautology. So it's got to be, one of those arrow statements where all the answers turn out to be true. So in this problem, they said the table at the left, well, for me, it's the table on the top. The table at the left gives the truth values for the 3 statements A, B, and C. Find all the implications. And you're probably thinking, well, I don't see any if-then statements. Yeah, so you got to make them. So notice I just started if-thenning. All right, how about if A then B? How about if A then C? How about B then C? How about B then A? How about C then A? And how about C then B? That takes care of all of them. Then I started making a truth table. Anybody tell me why I quit here? Why did I quit in this column right there? Yeah, I did if A then B. Only false when what? The first is true and the second is false. So this one, you can see, my pen bugged out.
Well, you ran into a false and you're looking for all true, so there's no reason for you to finish it, right?
That's exactly right, Elliot. So because, my pen is all of a sudden not working. Sorry. But because the second row turned out to be an F, I don't need to go any further like Elliot said because I'm looking for a tautology. Well, that's no tautology. So on to the next. So you see I started working on if A then C. Oh, and I was doing so well. True, 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 false. So that one's out. But then you notice I struck it rich on if B then C. It worked. Tautology. So B then C And it also works that B then A does, and C that, so in this case, three of them came out to be tautologies. So therefore, here they are. What are the implications? B implies C. That's this one right here with the extra stripe. I promoted it because of the tautology. And then the next one's in this column. This one's right here. And that one's right there. And again, you see how I promoted it by putting an extra stripe in there. So a problem like this, you look at it and you go, I got to make all these if-then. So your biggest job is you got to figure out how to come up with all the combinations. So I start with A and say, well, let's do A and B, A and B. All right, I'm done starting with A. Now let's start with B. B then A, B then C. All right, I'm done starting with B. Now let's start with C. C then A, C then B. Okay, now I got them all. And then just work out your knowledge of the if-then rule and see if you get any tautologies out of it. I hope you guys made some sense out of that. This one always throws people a little bit off. Anybody a follow up on this? I'm looking, somebody's asking about 23 or 24, and I will go look at those next. But anybody else on 17? So the final answer is there are three implications, and here they are. B implies C on the bottom, B implies A, and C implies A. Now another problem, you might only have one, or who knows? Yeah, and don't quit when you only get one. They're asking for. Notice the words here, all the implications. So you've got to keep looking, look at each case. Okay, I'm going to 23 and 24. 23. So 23 is use a truth table to check the validity of the following argument. If you win the race, you are a good runner. Second premise, you win the race. Conclusion, you are a good runner. So here's my coding over here on the left. If you win the race, then you are a good runner. So I coded that as if W, then R. You did win the race. W, same letter we just used. Conclusion, you're a good runner. So therefore, R. Premise 1, premise 2, conclusion. So 2 rows, W, R. Remember, you always want a column for each premise and one for each conclusion. That's why I have 3 columns over there, P1, P2, and C. By the way, I actually think it's important that you label these like this, because if you don't, you could forget a column and then you won't have your evidence. Well, anyway, once you've got it set up, this is a pretty straightforward, wow, this is really a pretty easy truth table, because W and R, well, we already did those when we set up the table. So really all you had to do is this if W then R. So anyway, how many rows have both the premises true? And notice in this case, it's only 1. So this time there's only 1 row where both the P's are true. And I see nothing but a true conclusion. Therefore, for 23, this definitely is a valid argument. Again, you could use different letters than I did to oh, I gotcha. Yeah, Ron was just asking, is 24 the only problem? Is 24 the only problem I'm throwing out? I believe so, and my apologies for not knowing. Yes, I've believe so, Ron. I think that's the only one that deals with a portion that I did not teach you about that. Okay, so anyway, we did an extra problem. That's fine. So, you know, if this was on the test, it says use a truth table to check the validity. Obviously, I would be looking to see that you made a truth table. And by the way, on the test, when I have you do a truth table, I give you a little grid so that make it a little bit easier for you to set up your columns and your rows. Please, when I give you a grid on the test to fill out a truth table, you do not have to fill in every box. That you know, there are different styles for truth tables. Well, what's important is you have enough to get your argument done. Don't feel like you're obligated to fill in every box. I just give that to you as a workspace. That'd be like me right here. Do you see how I left a bunch of boxes blank? Yeah, that's fine. As long as I've finished setting up the argument. Okay. You guys have asked good questions. Thank you. What would you like to do next? I'm hearing a question coming. That would be great. No, I guess not. Anyone?
I had a question about 11.
All right. Okay, so here's number 11. Under what conditions is the following statement true? Sally is naturally beautiful, or she knows how to use makeup. So I coded it, so it's a little easier to talk about. So if she's naturally beautiful, I call that N. And if she knows how to use makeup, I call that M. And or, I assumed, whenever they don't tell you which or, you can assume it's the inclusive or, which I did. So N or M. When will that be? When will that be true? So what they're asking you is, when is an or true? And you know how the rule goes. It's only false when both are false. So basically, 3 out of the 4 scenarios will be true. So that's what the meaning of mine is. So because it's an inclusive or, and the rule for that is only false when both are false, that fits here too. Only when Sally is not naturally beautiful and she does not know how to use makeup, that would be the only time it would be false. So all other cases would be true. So in a way, they were kind of asking to see if you knew your rule for or. Another good question. Thank you. Anyone else? We're at 50 minutes here, but I wanted to just see anybody has been waiting, and somehow maybe I didn't see your question.
So even though it wasn't in the test, would we'd still be responsible for the exclusive or?
Yes, that's correct.
Okay, thank you.
What's that?
I just said thanks.
I didn't quite. Oh, okay, thanks. Yeah, and you'll find actually it provides a big advantage. The exclusive or allows you to say something pretty complicated in a very simple way. Was there any, I gotta just take a quick peek at the front page here. I'm just looking. Yeah, I don't necessarily see any on there, but but anyway, to answer your question is, you need to know the exclusive or, and you're right, the practice test did not, well, they didn't teach it, so they didn't ask you anything about it. Thank you for reminding us of that. That's important too. Well, okay, in the interest of management of time, and it's getting kind of quiet, I'm going to call it quits tonight. Let me remind you that Wednesday we will continue questions in study mode, and we will end, and then we will eventually move toward the test. I'll remember, I'm letting you use your notes throughout this test, so I will collect the notebooks after you have completed the test. Don't forget to get your notebooks ready to go, everyone. And don't forget about the extra credit opportunity in your notebooks. Any final questions? All right, then I'm going to say good evening. Thank you for joining us. Thanks for joining in tonight. I look forward to seeing you on Wednesday.
Thank you.
Have a good
Have a
night.
good evening.
See you Wednesday.
Some of you I may get to see earlier if we have an appointment. That'd be, or even if we don't have an appointment, come and see me.
Okay,
Night.
thank you.
Bye, everybody.
Bye.
Bye-bye.